Ladies and gentlemen, welcome to this presentation. I very much appreciate the opportunity to being here today on the conference and your interest. My name is Frank Kirschke-Biller. I'm working as the head of the Department for Process Methods and Tools for Electronics and Electrics at Volkswagen. This includes as well the lead for compliance effort and for functional safety. I'm looking forward to present to you today Agile Systems Engineering, which is from my point of view an interesting topic, and you may wonder why I talk about good old systems engineering on an event which is focusing on how to become a software company. So the question could be simple by giving a reference to the ASPICE model, which includes as well systems engineering and not just software engineering. But I believe that system engineering plays a major role in managing complexity, and so it's a foundation to become more agile. Good, what's motivating us today? The automotive industry is in a significant change in the last 10 years or even more. Rather simple system like traditional infotainment became very feature-rich and smart aspects of the vehicle, similar to functionality you're having on a mobile phone. And today we're talking about connected vehicles. What was active safety in the past is driver assistance today, and it's paving the way towards autonomous vehicles. And there are plenty more examples of that growth. So we are heading into a world which you can define as smart mobility, where you cannot have a look only on the vehicle, but as well on the vehicle as an element of an ecosystem. So the boundaries are expanding from onboard functionality as well to offboard functionality. All that is driven by a tremendous growth of software. And I believe that's why you are here today, because that's driving you and challenging you as well. Software is eating the world, is one famous quote in that area. But it's not only about software, it's as well about a tremendous change and growth in complexity and architectures. So in the past, we had local features. Today, we have hundreds of distributed features in the vehicle. And we are moving now towards zonal architectures and centralized computing power. So to be able to manage software and master software, you need to be able to manage the complexity and the architectures. And that's an important challenge. So are the processes we are having right now able to cope with that challenge? The traditional kind of waterfall approaches with planning, concept phases, and so on are the standard in the automotive industry. If you look on how they work, you will find several issues. The concept is stage gate oriented with hard requirements free state, but unfortunately on those free states, the specs are not mature, so it's followed by frequent changes. The timing of deliveries is very much defined by prototypes and vehicle build dates, so driven by mechanical parts and maybe not suitable for software. So the entire process framework needs to be refined to become more software-oriented. So if you see that changes are coming anyhow, we need to be flexible on changes. We need to be able to deliver software updates in a continuous way until job one and beyond. So agility looks like the right framework because it's all software. But be careful, that's not the truth, because agility alone will not allow to manage the before mentioned complexity. So to be able to handle the growing complexity in the car and in the architecture, you still need very strong and even more capable systems engineering. And we are using the RFLP methodology, which focuses on requirements, on a functional view, on a logical view, and on a physical view. And that is a way to break down the complexity and make it manageable. On the other hand, even with that, there are still many uncertainties, especially on new technologies, where the room cannot be defined completely by spec work, but as well you need to have practical experience. That's where the agility is coming into place and will play a role. So for the future, we believe that any framework for development needs to combine systems engineering and agility, and that is what we call Agile Systems Engineering. So what needs to be considered when you go that way? And I'm using here a slide being provided by Christoph Ebert from Vector Consulting. Here the statement is you have 4 dimensions to be considered. One is people, because you need to change the culture, you need to change how people behave. You need to change the processes and the technologies, and as well on the business side, there are plenty of changes. Today we'll focus on the process and technology side more than on the others. Now, when you look into the agile values, like working solutions over comprehensive documentation or responding to change over following a plan, and compare that to the way we have worked in the past, you will easily understand that changes are required. 4 areas are, from my experience, key to success here. The first is architecture. You can't define architecture as a given in the early phase of a project and then not touch it. You need to be able to change architectures over time and be flexible, and I will speak about that in a minute. The second element is the way how you do requirements engineering, not only text-based, but model-based. Models are executable. You can experience how a model works. You can put that in front of a customer. So model-driven engineering is far closer to a working solution above or over comprehensive documentation. Project management in a traditional world is significantly different from project management in agile work. So instead of rigid integration phases or free states for specs, you need to allow updates over time. And I will talk about that in a minute. And the relationship between an OEM and the supplier, of course, needs to change, not only to cover new project management aspects and things like that, but as well to create a collaboration which is based on trust and more flexibility than we had it in the past. That as well is key to success. So we need to tailor our processes to be future-proof. Now, in the past, architectures were designed very early in the system V and then more or less frozen, so the variable until part was rather limited. What we believe is that in the future, the architecture needs to be more variable because we are learning on the way. We are learning how features behave, what customers want. And we need, on one hand, to have headroom in the architecture, which allows changes. And on the other hand, we need to be flexible over time. And maybe even after a launch, we need to provide a level of freedom and variability to the architectures. We can't stick to the single system B approach like in the past, but we need to have a series of development phases of sprints. So with that, we need to be able to do updates and react to changes, and architecture will become an ongoing process. We're trying to do that. We can't do that in the traditional way. I would not say only paper-based. I think there were smarter ways already in the past. But in the end, to manage changes on such complex elements like vehicle architectures in a short time, you need to have models in place which supports you. And that's pointed out on the next page. So the RFLP methodology I described is reflected here. You usually start with stakeholder needs and feature definitions which define what a customer would see from a feature, not how it's done. And that will be the foundation for your requirements. That needs to be broken down into logical functions. That's called logical architectures. And the logical function then will be deployed on the physical architecture, on the components, which then gives you the spec and the content from component side to be considered. So that's the kind of RFLP in a nutshell. You need to ensure that legal requirements, functional safety, security, and so on are captured as well. So there is more than just the functional content. If you do that, on the next page here, you see how that can be done in a SysML environment. And we would recommend SysML as a kind of leading standard for architecture work in the vehicle, because it can give you, it provides you the functionality to detail out the architecture, as well as it will provide you the functionality to do the model for the functional side. So it's a very comprehensive toolbox. So if you have control about your system, and if it's described in such a structured model, then you are far more open to changes. You can conduct easily an impact analysis if something is changing, so you are prepared for a more agile way to work and you have full control about your system. I think in addition to SysML, I think AutoSAR XML is probably a very important standard too, because it provides standardized interface to the software world, which is creating a stable and very capable link to the architecture side. Now, having said that, it's not all about architecture and requirements separately, and what I described before is not a you do that once approach. When you go through the different levels of a system, you will always create new requirements, think about what that would mean for the architecture. So there will be a kind of zigzag between system requirements and architecture along the way. And as well, when you apply agile principles and start to do early implementations, then you will see what's working, what's failing. And from that experience, from the first software iterations, you will gain as well new requirements and change requests to the architecture. So you will be in a constant move, so to say, and that is what system engineering in an agile way needs to provide in the future. Now having a closer look into what does that all mean from a software company standpoint or from an agile software project team. An agile project team, probably on the component software level, will need to work in a framework and into constraints which are coming from legal requirements, from functional safety, cybersecurity. There will be constraints from the architecture, probably dedicated software requirements, design rules, and so on, and plenty of functional requirements for the function the customer would like to see, the interfaces being described. So a project will always work into that framework. And it's important that the interfaces needed to do that are well described between the software teams and the system engineering teams. If the interfaces, if the tools, the process and methods are well defined, you can run all the development cycles in a high speed, and you can make use of the benefits of agility, testing early, failing early, and reaching a level of maturity. So the alignment of tools is really, and the processes is really a key enabler. On the other hand, you need to define as well which level of documentation you need from an agile team, what is part of the definition of done, so that you can take all the results from the project work and bring it back into the bigger picture of project management. So that's important, and the alignment is not easy because the software tooling and the systems tooling are normally not exactly the same in many companies. So that's a tricky area. A second aspect on this slide to be considered is when you do your architecture right, you can try to give agile software projects a maximum of freedom. So if you cut the functionalities in a way that the interfaces are limited, you are more flexible to do the work. So we had examples for in the infotainment area where you're running a lot of local functionality. Here you can run an agile project with a lot of freedom, and that's beneficial, of course, for the software engineers. Now, the next element to be pointed out is project management and project management requirements. When you do classic project management, you're following strict processes. So you can say it's driven by the process and by the milestones and the gateways. In agile project management, you would always be driven by the product and by the value you create. So it's a completely different philosophy, and you need to combine both, which is easier said than done. On one hand, you need to establish that in your company at an OEM, there is an agile culture. So it's important to embrace change, because the change in the end means an improvement of the product and creating higher value for the customer, instead of arguing on change requests and the cost and so on and so forth. So that's a cultural change being important. And of course, you need to have cost control as well. Then you need to integrate the traditional milestones and the project plans with Agile sprint planning. You need to align what the OEM is doing with the release trains and solution trains on the software side, probably have joint PI plannings and stuff like that. So you need to synchronize your product backlog planning across all development partners. That level of synchronization I believe is key, especially when you work with larger teams, with larger agile release trains, because if a feature is distributed, one partner being not ready can stop the entire show. So you need to have a level of control to ensure that the system provides managed feature growth over time. And to do that, of course, you need regular status tracking, which can be earned value based, or you can use a feature maturity model, use other metrics like technical debt or issue counts. So going into a more agile project management framework still means you need to have control on what you do to reach your objectives. And that cannot be done by standardized processes. You need to tailor your way here. That's important. Okay, so that's the kind of general view. A few slides on what we're doing at Volkswagen in the moment. In the past, we approached system engineering and the transition from component-centric design, which was dominant for many, many years, to function orientation, simply by the need of distributed features and functions we are having in the car today. We did that based on a structured approach with a group-wide feature dictionary, specification for functions were implementation independent and could be reused. Functional realization specifications had been in place, including the architecture and the target platform. The roles for that work had been applied accordingly, and to ease requirements engineering, all that was supported by templates, libraries for standard requirements and so on, and ended up in component specification. The base technologies are aligned at Volkswagen across the entire group so that we can reuse parts and technologies in all brands. So that was the past, and it worked rather fine, but that's not suitable for the future. If you have in mind what I showed you on the first page in terms of new challenges and changes, we are now approaching the work with a new setup, which is full-blown systems engineering and a refined information model. So it means that we are moving into a new kind of model which reflects a system level 0, which is a system of system, including our clouds, probably clouds of business partners being required. So that covers the complexity we are having meanwhile. The information model now is structured into system engineering levels. So there will be level 1, which is defining the entire vehicle, being broken down into main systems, subsystems, and from there into the component specs, where we now separate hardware specifications and software documentation. So that's now in place. There is a handshake model between all these levels to ensure that requirements are traceable and known by the customer or by the people which are receiving requirements. So that's following system engineering principles, and the organization is just changing to reflect that. So the organization will be structured along the lines of those main systems, along the lines of logical architectures, and that's just implemented. The supporting templates, libraries, and so on remain because they're good value for the corporation, and there is now a stronger focus on the interface to the software side of life, especially with CARIAD as being our in-house software partner, which is part of our plan. So with that, we are heading into Agile Systems Engineering in practice. So we are just changing the way how we operate. The CARIAD is already highly agile. We were more traditional in the past, so we are building that bridge right now with a structure which needs in the future to allow architecture and specification updates over the time, including a project management with implementation planning, backlogs, and status tracking, as I alluded before. So from the planning side and the specification side, instead of gateways, we will have more a kind of solution train where we hand over frequently the updated material to the supplier, e.g. CARIAD. And on the other side, there will be an agile release train, which will continuously build new software, do the integration and the testing so that we learn as early as we can about weaknesses. And that is what we do as a transition into Agile Systems Engineering. So it requires changes in our processes and methods and tools. It requires close alignment with CARIAD as our in-house partner. And of course, the organization and the culture are going to be changed, and that's what we are working on in the moment. Okay, with that, I'd like to come to an end and provide you a summary. So the growth of functionality and complexity in the car is going to evolve more and more. There is no point where the technology is shrinking again. So we will see more and more functionality, more and more software, more and more complexity in the future. And the only way to handle that in an efficient way from our point of view is to combine system engineering, being the enabler to manage and master complexity, with agile principles to see implementations earlier, to handle uncertainties and become more flexible. So OEM-specific concepts for agile system engineering are required. There is no industry standard for that. And when you start the journey into agile system engineering, as I mentioned before, you need to consider people, processes, technologies, and the business and the value focus is very important here. BW is evolving on that right now as we speak. So we are strengthening system engineering. We are more and more utilizing agile principles, building a strong interface for process methods and tool with Carriot as a key enabler to do that. And as we as a company work, of course, with other suppliers as well. So agile collaboration in general terms between OEMs and software supplier remains to be an opportunity. And there is a VDA activity which closed the work a year or so ago on agile collaboration, and maybe that's interesting for you to have a look into that as well. With that, I'd like to thank you for your patience and your interest, and appreciate your questions now. Thank you very much.